go. Okay. Today is June 7th, 2016, and we're with Tim White, President of the Electronic Systems Business at United Technologies Aerospace Systems. Thanks for being with us, Tim.
Thank you.
The electronic systems business at UTAS is quite extensive. Where are you today in terms of the market for electronic systems on aircraft, and where do you plan to be as you grow over the next 10 years?
Sure. We're the leader of the market in providing power generation systems, distribution systems, and emergency power sources for both the commercial and Western-built military aircraft. And as we prepare for both the rampant commercial aircraft and the further evolution of more electric aircraft, we're now looking to continue to invest and prepare ourselves for newly launched aircraft in the coming decade.
You've invested already in some programs. I know you guys are on the 787, probably the electronic leader in the commercial side, and also the F-35, which is certainly a complex military platform that you probably can't tell us all the bells and whistles about, but it's certainly state of the art. What experience have those programs given you, and what advantages does that give your operation?
So the experience that we have with the more electric aircraft architecture, it's allowing us to start thinking about how do we innovate for the next generation of more electric aircraft. And when we say more electric aircraft, it's really about providing systems to both our airline customers, our military customers, and the OEM customers that operate the aircraft more efficiently and allow the aircraft to meet its overall mission needs, whether it's improved fuel burn, improved performance in the military. And so with our experience on platforms like the 787 and the F-35, we're now starting to look at how do we innovate and get ready for the future.
How does an electric system help an airline, say with the 787? How do you translate electronic systems into better fuel burn, for example?
Sure. I'd love to answer that question. On the 787, the way the systems architecture contributed to the fuel efficiency of the aircraft was the traditional systems that provide cabin air temperature control and compression were typically driven by bleed air extraction from the engine. And when you have a very long-range aircraft like the 787, when you would take bleed air off the engine, that's an inefficient way of extracting power from the engine. The theory of the more electric aircraft architecture on the 87 was to pull that power off mechanically, convert it into electricity, and then power the environmental control systems electrically. That is what essentially enabled significant contribution to fuel burn reduction from the systems architecture.
So the electric power, certainly the needs are growing as everyone wants Wi-Fi on board, everyone wants to plug in their laptop. Right. The systems themselves with more sensors on the airplanes are drawing power. How much of an increase do you anticipate in the power requirements for an aircraft over the next decade?
Right, so what we've seen on current, I'll say first generation more electric aircraft technology, we've seen up to a 5-fold increase in the demand for electric power. As we look at the second and potentially third generation, where we're talking about some aspect of electric propulsion potentially, or hybrid electric propulsion, we're seeing almost another 5-fold increase in the electric power demand from aircraft. So we're starting to talk about megawatt class systems, and when we look at how we're investing and what are some of the fundamental base technologies we're investing in, we're looking at the ability to generate megawatts of power from the aircraft engine and convert that power and then distribute it throughout its network.
How much have you invested in this power generation business? You're on most of the major programs now going forward, the Neo, the Max, the C-Series, the 787,
right.
777X. What kind of financial resources does that require, and how do you generate a return?
Sure. So that's a great question. We've invested, and I'll broaden the question on both the power generation and power distribution side, but also all the loads that we've had to convert from either pneumatic or electric. In the last decade, there's been approximately $3 billion spent by the company and developing the core technologies, designing, developing, and certifying and putting those systems into service. And what that's led to not only has been the investment, but the output has been the systems, but also innovation. We've issued around 1,000 patents in that time frame as well, or been awarded 1,000 patents. We have several hundred additional patents that are in the application process. So the investment has been significant. The returns are also significant as we look forward in the next 10 to 15 years, because we're really in a good position to secure the industrial ramp. And when you look at, I won't give specifics, but the average ship set content for an electrical system on the newer generation aircraft is approximately 2 times the more traditional aircraft architecture. So our revenues are significantly increasing and growing faster than just the growth rate of the overall market.
So as the overall market grows at a 5 to 6% rate, you're doubling on each aircraft, so you could be approaching double digits, assuming a 1-for-1 transition.
Correct.
That's an impressive growth rate. What differentiates you from your competition? Is it the technology that you've patented, and how will you continue to maintain leadership over the next decade?
Yeah. So there's really there's 2 things that we focus on with our customers. One is delivering innovation and value to them from a performance perspective. But the other thing that we really focus on as a business, we have a long legacy of providing power systems to the entire industry. It's our ability to support after we've delivered that initial equipment to our customers. So customer service, customer support, and ongoing investment in the product during the life cycle to make our reliability ever improved. We're still investing on platforms that we put into service 20 years ago, and implementing and putting in technologies that make our products more and more reliable.
That's great. Thank you. Thank you very much.